Okay, in this video, we're going to start by finding the zeros of this function, this polynomial function. So the way we do that is we put in 0 for f of x. From here, we're now going to factor. So I'm going to factor out an x. So if I factor out an x, I'm left with x to the fourth plus x squared minus 6. Now at this point I can factor the trinomial, so I get x, this becomes x squared plus 3, x squared minus 2. Again, my inside and outside terms are going to add up to that positive 1x squared. I can now set x equal to 0, so there's one of my zeros. I can also set x squared plus 3 equal to 0. So when I subtract 3, I get x squared equals negative 3. Now, when I take the square root of both sides here, that's going to give me an imaginary 0. So we're not looking for the imaginary zeros. You know, I take the square root. Again, the negative under there tells us that it's imaginary. So again, that one's not going to count. And then the other one, x squared minus 2 equals 0. I add 2. So x squared is going to be equal to 2. Take the square root, and I get my other two zeros, which would be plus and minus radical 2. So my zeros are 0, plus radical 2, and negative radical 2. Okay, so when I check now my zeros for their multiplicity, 0 appears once, so that's a multiplicity of 1. Radical 2 shows up once, that's 1, and then negative radical 2 shows up once. So all of those are odd multiplicities. So when we go about sketching our graph, the reason that's important is because if we have an odd multiplicity, that means that on our graph, it's going to pass through that point on the x-axis, and it's going to continue going through that point. Whereas if it were even, it's going to touch that point. It's going to be a turning point going back the other way. So that helps us there with our multiplicity. The next thing we're going to find is our maximum number of turning points in our curve, which the maximum number of turning points is our degree. So the degree minus 1, which in this case the maximum number of turning points is going to be 5 minus 1. So maximum number of turning points would be 4 within the graph. Again, that's maximum number of turning points. Now, if I were going to go ahead and make a graph of this function, I'm going to utilize my zeros. So at 0, at radical 2, which would be about right here, and at negative radical 2, which is going to be about right here. Now, we've already learned about end behavior, so we know that this particular coefficient is positive, and we know that it is odd. So we know that the end behavior to the right, it's going to be rising. To the left, it's going to be falling. Now, one of the things that we might do between the points is we might just kind of check and see. We know that since the multiplicity is odd, it's going to pass through each of these points on the graph. So what we might do here is go ahead and plug in some values just to kind of check. So if I plug in, let's say, a value between 0 and here would be 1. If I plug in 1, that would be 1 to the 5th is 1, plus 1 to the 3rd is 1, minus 6. So when I plug in, that's 1 plus 1 is 2. 2 minus 6 is negative 4. So just to give me another point, 1, negative 4 is going to be down here. If I plug in, let's say, -1, well, that's going to give me -1 plus -1, so that's -2. And then -2 plus 6 is going to be 4. So at -1, I'm up at 4. Okay, so that kind of gives me at least another point here. So for me to be able to kind of sketch my graph, it's going to look something to this effect. Again, may not be the lowest point there, but again, kind of goes back up and then back down. So again, that's just a rough sketch of what the graph is. And again, we could check on our graphing calculator just to see if we are on the right track here with that. So let me get the graphing calculator here. So if I turn on my calculator, y equals, I'm gonna go ahead and clear out my y, and I type in x to the 5th plus x to the 3rd. Let me delete that here. Again, plus x to the 3rd minus 6x. If we take a look at what our graph looks like here for that, and again, you can kind of see our sketch pretty well mirrors what it says here, and so we did that correctly. Good job.